Setting up differential equations can be quite tricky, so today we're going to go through exactly how to do that. We've got a cuboid tank here with water coming in, water coming out, and we need to find an expression for dH over dt. So we know that dH over dt is going to be the rate of change of h due to inflow, so water coming in, add on the rate of change of h due to outflow, so water going out, and we know that's going to be negative, since if you take water out, then h will decrease. So we know the rate of change of h due to water coming in, that's going to be the volume of water going in divided by the base area, which is 3 times 8, and we get 1 over 50. We know the rate of change of h due to water going out, that's going to be negative, since water going out will decrease h. So that's going to be the volume of water going out, 0.1 h, divided by the base area, and we get negative h over 240. Plug in everything into our dH over dt and multiply both sides by 1200, and we get the required expression. That's the first example. The next example, we've got a paint mixture, and we need to find the rate of change of red paint in the container and the constant A in that differential equation. So we know the rate of change of red paint, dr over dt, that's going to be the red paint in, subtract the red paint out. We're also told that the red paint is mixed evenly throughout the container, so we can find the proportion of red paint in the container, which will be R, which is the amount at any time in the container, divided by the total volume in the container. And you can see 3 litres go in per second and 3 litres go out per second, so the total volume will stay constant at 30. So we can find the rate at which red paint leaves the container. That's going to be 3, which is the total volume leaving the container, times R over 30, which is the proportion of red paint in the container, and that's just going to be R over 10. Plug in everything into our differential equation, and we find our constant A to be 10. So, it's pretty hard modelling differential equations, I think. It might be harder than actually solving differential equations themselves, but once you get the gist, then it's pretty much straightforward from there. Good luck.